In this session, I'll be introducing our mentor for today, Mr. Adetomiwa. So I'll be reading his profile so everyone can get the details about him before he begins his presentations and all. So Mr. Adetomiwa is a nationally recognized energy leader and the CEO of QTech Nigerian Limited, with expertise spanning electrical engineering, hybrid power generation and power distribution, metering, renewable energy, and energy efficiency. He serves as a consultant to the Nigerian Army, Navy, and Air Force, delivering over 75 billion in savings through smart metering, hybrid solutions, and transparent energy accounting. He has advised most of the notable electricity distribution companies in Nigeria on metering, revenue protection, debt recovery, and distribution franchise rollout. Recently, he led the power system diagnostic and implementation of the Ekiti State electricity market strategy and is currently supporting the Office of the Vice President in shaping Nigeria's subnational electricity frameworks. He is a certified current and NEMSA person, and he also participated in executive programs at MIT, Columbia, Dartmouth, UT Austin, and EIT Australia. Studying Ayotomiwa is a pioneer in design thinking, strategic innovations, and energy systems. So please, everyone, can you welcome Mr. Ayotomiwa to this session? And please signify if you can hear me.
Yes, we can hear you.
All right. So, Mr. Ayotomiwa, the floor is yours, sir. You're welcome.
Thank you. Good morning, everyone. If you're in Africa, and if you're not, good day to you as well. Can you all hear me?
Yes, I can hear you.
Excellent. Let me turn my video as well. Can you hear? Excellent. Thank you for that introduction. Just as she said, my name is Ayotomiwa Adekahunsi. I'm an electrical engineer. And today I'm hoping to have an exciting session with everyone who's joined this fellowship and mentorship program. And today we'll be talking about how energy is changing the energy landscape. And I've tagged it WhatsApp. It's a small coining of, the unit of energy, watts, and of course the colloquial greeting, what's up? Essentially, I would like to give you a quick background on the electricity landscape across the world. And perhaps maybe when we understand how energy is being created, distributed, and eventually used, we can together start thinking about the how technology can then impact the different sphere. Across the world, generation, is where electricity starts from or energy starts from. You have to generate energy. And then when you start talking about generation, you start talking about different sources of fuel. So some experts would even argue that the value chain, in fact, starts with the fuel co, the company that provides the fuel, and you have the fuel co first, then have the genco, who are the generation companies. Then you have the transmission companies, for short, we call them transco. And then we then have the distribution companies, which we call the discos, right? Then the end user, which is usually you and I, your factories, industries, situated in very different places. Okay, so let's start with the fuel cores. Oftentimes across the world, one of the major ways to generate electricity is through fossil fuel. Okay, and fossil fuel, I'm sure that you're conversant, would be things like petrol, diesel, gas, and in gas, you're talking about CNG, natural gas, liquid, LPG, and things like that, right? In Nigeria, most of our electricity actually comes from gas or thermal generation, right? And that's why the cost of crude oil or the cost of gas greatly affects, the pricing of electricity. But of course, you and I would not know that because most of our governments across the country, across the world, subsidize energy, for its citizen, and that happens on a large scale, especially in Nigeria. A lot of parts in Africa, not as much as Nigeria. Actually, Nigeria actually heavily subsidizes electricity for its customers or for its citizens. So you have the fuel cores, and in this case, if we use the Nigerian case study, most of our generation or most of our fuel comes from gas. Other sources include hydro, which is another huge source for Nigeria. The next greatest source is the hydro. And in this case, I'm speaking about the grid as a whole, right? When we then start to talk about decentralized grid, then you're now talking about heavy usage in diesel, and of course in petrol, or and in very recent times as well, we speak about gas generation. Very quickly, I just said about decentralization and centralization. So let me quickly explain what that is, and I won't just assume that everybody understands what that is. So there are two ways to deliver power. You can have a centralized grid. Most of us in Nigeria have heard of the national grid, and we always hear that it collapses and things like that. So what's the national grid? So when energy is created in different sources, it comes to a central point, and then that central point then dispatches that energy based on various prerequisites. So for example, it could dispatch based on location, dispatch based on consumption or demand, or national security, and things like that. The grid is also in charge of balancing, generation vis-a-vis the demand, right? Then decentralization essentially means, and of course, the grid, what happens in the situation of a grid is that most times the generation companies are very far away from the load centers. The load centers are places where you and I reside or use electricity, right? And then that power is brought, from those remote areas or very far areas and dispatched and brought all the way to you and I, right? But then in decentralization, you then find out that your energy asset or the generation assets are much closer to you. So it could be your own personal generator, or maybe you have a generator for your estate or for a small community, and of course, both of them have their merit and demerit. One major merit the centralized grid has is that it's able to make energy cheaper, and hybridization is also very important or very useful in that scale. Whereas the demerit is that it could be very unreliable. And of course, when there is a fault, a large number of people will then be affected, unlike decentralized grids when you have your generation very close to you. But again, that could be a bit more expensive in capital expenditure and of course in operating costs, right? But then the advantage is that when there is a problem with the national grid, you're not affected, or you're able to start it up quicker and faster than the centralized grid. At any point you have any questions, please just take notes, and at the end I'll try and wrap up a bit early so that I can take as many questions as possible. Unfortunately, I don't know your backgrounds, So again, that's why I'm taking my time to explain a bit more some of the terminologies that I'm using, so that, you know, I don't assume that you understand all of those things. But of course, if you have any questions, please do not hesitate to take notes of all of them, and then I'll take as many questions as possible. So very quickly, we talked about the fuel, then we have the generation company. So the fuel company delivers fuel to the generation company. I must also add that there are some fuel sources that are called renewable sources. So essentially, they're naturally abundant sources that are never ending or and self-replenishing. So for example, like I said, hydro, for example, you'd see that hydro is a renewable source because water is the major source there, and it's renewable and self-replenishing, right? You have the sun, which we call the solar, right? You know, again, that's another renewable source. So in this case, God is the supplier of those sources. So you don't have to pay anybody, unlike the gas companies or the fuel companies that I spoke about, right? And then you have the generation, which then takes that fuel or that source and converts it to usable energy that would turn into electricity. Most times they're done with huge generators. Most times they're remote, in remote places. In terms of hydro, you're looking at very big power stations that have very big turbines, right? In the case of solar, you have things like solar panels who are then hybridized with one form of, you know, battery storage generation or gas or whatever you choose to hybridize. Now, what does hybridizing mean? Hybridizing is just, you know, taking different sources and mixing them together and just using them at maybe different times, you get, to be able to meet your demand, right? Generation, you know, in terms of solar, you have things like solar panels. In terms of wind, which is another fuel resource, well, you're talking about those huge wind turbines, right? You know, and then once you do that, you recall I said that for generation, most times they're in outskirts or in very far parts of the country, and sometimes they're even in other countries. So for example, Nigeria supplies power to the West African power pool, which includes, you know, Togo, Niger, you know, and some other West African company, Benin Republic, and things like that, right? So it could actually even be in a different country. The power that I mean, the lights bulb, when you turn on the light bulb, you don't even know exactly where that exact power is coming from, right? So that's the work of the transmission company. They then think of the transmission company as a logistics company for the power sector. So they take power from the different parts of wherever they're coming from, different sources. It could be from solar, from hydro, from gas, wherever they're coming from, and then dispatch them, you know, to where they're needed. And most times they're then handed over to what we call the distribution companies. The distribution companies are the guys who you and I see, right? Every day, the power companies that actually come with bringing your bills, supplying your transformers, your cables, service cables, and things like that. So most of the times we interact with the distribution companies the most, whereas we don't see the generation companies or the fuel companies or the transmission companies, right? The people we see most times are the distribution companies, right? And the money that you pay is then, you know, broken down in different fractions and sent back to the different people in the value chain. So for example, if you paid 209 naira, for example, or maybe $5, you know, per kilowatt hour, it is shared in different proportions such that the gas company will be able to get his own share, the generation company will get a share, the transmission company will get its own share, and then you have what's it called? The distribution company getting their own share. Now, why have I taken time to break down this, right? As you can see, I mean, if you're very intuitive, you'd see a lot of opportunities. Okay, so number one is huge data collection, right? Especially now that we're in an age of machine learning and AI, right? There is huge data collection that has to happen at every point. Do you get? So let's take, for example, the gas supplier. The gas supplier must be able to tell how much gas is supplied to the generation company. and their books have to align. Do you get? So for example, the gas company cannot say, you know what, I supply 10 scoffs. And then at the other end, the generation company is saying, no, we only got 5 scoffs. Now, in principle, that can happen, right? There could be a problem, maybe in the pipeline or with the measuring devices and things like that, right? So again, and one of the case studies or assignment that I'll give to you is to look at what Saudi Arabia is doing when it comes to the transportation and the technology behind the infrastructure behind the safety of gas dispatch, you know, and also crude oil dispatch across their value chain. The Saudi Arabia has done this excellently in the sense that every drop of oil is accounted for from when it's brought, you know, brought out from the earth and transported all the way to wherever it's been used, either been shipped out, you know, for export or used for fuel or refined for other products, right? You know, so you have, you know, an enterprise, a system that is built around, you know, sensors, right? Remote sensors across different value chain to track this this assets, right? You know, and these assets are very expensive. In many cases, could you mute, please? Okay, thank you. In many cases, a lot of economy, and I'll take Nigeria again, and you know, Saudi Arabia, and a lot of the countries in the Middle East, the energy is correlated with the health of the economy. So to put this more simply, if Nigeria, if Nigeria, for example, stops selling oil today, then inflation is going to go up. And essentially, in summary, it's going to be harder way to live in Nigeria. It's going to be harder to live in Nigeria from an economic standpoint, and you know, it affects every sphere of the economy. So you see, that's a very important and expensive asset, and that's why we do a lot of tracking around those things. And if you remember earlier on, I spoke about how because of the cost of energy is being subsidized by most governments. But then because of the economic issues across the world right now, a lot of governments, including governments in Africa, right, are moving away from subsidy, okay, and trying to push for what we call the cost reflective tariffs, you know, across the energy value chain. And what does that mean? It means that let the free market work. Let, you know, if the cost of energy, if it costs me 10 naira, for example, or $10 to produce this energy, then I have a right to sell it at $12, including my own markup, right? And the customer should be able to pay that, right? Instead of paying $5 at the end user, and then the government then fits the rest. What has happened in the past is that the government is unable to do that, right? Which then brings us to the crux of the matter today, energy efficiency, right? Energy is very expensive to generate, right? And there are two different strategies, you know, that we can explore when we're talking about energy efficiency, right? So two different ways to look at it. If you have a fixed demand, for example, right? Or let's say your demand is variable. So there are two ways to meet your demand, right? If, for example, one way to look at it is to increase your generation to be able to meet your demand. Does that make sense? Right? Or reduce your demand and meet it with your existing generation, or such that you can even reduce your demand and then use less energy to meet those demands. And all of these strategies are being used in different spheres of our lives. So, for example, you may have heard of energy efficiency devices. I mean, if you are maybe as old as I am, you would remember that at one point in our time, in our lives, we had televisions that had these hunchbacks, you know, very big backs and things like that. And they would draw as much power as possible. I mean, if you're Gen Z, you probably have no idea what I'm talking about right now, right? Now you're used to flat screen TVs and TVs that are naturally just, more energy efficient. But I mean, if you go way back, you remember that even when you turn on your TV at that time, if you had a smaller generator in the house, you would see that that generator would, would try and go off and then come back up, because the kind of power that has come onto it, right? Same thing with our fridge and freezer, our heaters, and our ACs or air conditioning devices, and so on and so forth. Okay, so again, one of the things that a lot of investment or research is going into is to make our day-to-day product more energy efficient, to make them less power hungry than they used to be in the past, right? So we have more energy efficient fans, more energy efficient air conditioning, televisions, computers, and so on and so forth. Even our refrigerators and things like that. We've also tried to, then, look at generation as well, and also figure out, how to immerse more power from renewable sources, especially renewable sources such as the wind and hyd and solar, right? And that's where you hear that solar panels are becoming more and more efficient. Do you get more, and also taking up less space than they used to do in the past, right? So that we can reduce our dependency on fossil fuel, which again is naturally occurring but expensive to explore or to bring out of the earth, right? And of course, as we have started to learn even in the past 10 years, that even though they are naturally occurring, they're also a limited resource. So there are actually estimates now for oil wells for when they would go dry completely. And that's why you can see that even some exploring work is being done, elsewhere in trying to find more wells to explore, right? So again, we're thinking of energy efficiency, two major ways: reducing our demand, or making generation are more optimized, if you understand what I mean. So for example, and that's why I talked about, a lot of research going into making solar panels more efficient, batteries more efficient, and again, as I'm saying all of these things, I hope that you're finding, where technology plays a part in all of these things. Because again, what does technology do? Technology helps provide solutions to problems. So again, there's a lot of work in finding out better chemistry for our batteries so that, they last longer, their life cycle is extended, the backup time is extended, right? So a lot of people are looking into cobalt. There's a lot of work being done with lithium ion at the moment. There's a lot of work with zinc and nickel components, right? So there's a lot of research going into that, and there's a lot of technology going into testing some of these things and deploying all of these things. There's something called the battery management system, where people have then decided to develop, software, capability for even the hardware, and to be able to manage this asset or this resource vis-a-vis the loads, right? So this is one of the ways that we're looking at energy efficiency. And again, just to put things more in perspective, there's an energy challenge in Africa. Number one, we're not currently generating enough. And of course, as you well know, the population is exploding. Currently, is an estimate of 600 million people without electricity across Africa, right? And in sub-Saharan Africa, the annual cost of running generation exceeds $30 billion dollars annually, right? And of course, you can see, even with the issues of climate change, right? It's sometimes very hard to even predict some of these renewable sources at the moment. And of course, we know that in Africa, one of the major problems that we have is the ability to pay for energy because of the vast poverty across Africa. But then we have a huge opportunity. Africa has a big population, a youth population, and then, with youth comes innovation. And that's why in programs such as this, we're trying to challenge you and, trying to show you some of what those problems are and get you thinking in the right direction, and hoping that you would pick one problem, sit with it, and then, come up with a solution. So why is energy efficiency important? Number one, you're going to be able to lower your bills, right? I've spoken about how energy is expensive. Eventually, when the whole of Africa moves towards what we call a cost-reflective tariff system, then you find out that energy is going to be considerably more expensive than it is right now, right? And it just makes a lot of sense to figure out how to lower your energy bills. One way that a lot of people across the world are doing, and most especially in Africa, and maybe in Nigeria as well, or definitely in Nigeria, is energy theft. Okay, and that's not what we're trying to preach here right now, right? If you find intelligent ways to lower your bills, there won't be any need to steal energy. And it's estimated even at this moment in Nigeria right now that at least 65% of the energy users in Nigeria are actually, involved in one energy theft or the other, which again is crippling the energy sector in Nigeria. Okay, you'll find out that a lot of the distribution companies, and we have about 13 of them right now, including the state generation companies. You find out that liquidity is a problem for them. And what is liquidity? They don't have money to run their day-to-day programs and events that rely that has to do with generation and distribution of energy, right? Without the money or the liquidity, they're unable to invest in expanding or repairing or replacing their energy infrastructure, right? And that's one of the major reasons why there's epileptic supply of energy across Africa, because theft is high, right? And one of the ways to combat this is to, figure out intelligent ways to lower our bills. The next thing is environmental protection, right? We can't continue to burn fossil fuel, especially in Africa where diesel consumption is high, right? Almost every other house is self-generating by themselves and generating with one fossil fuel or the other. And you can see what it's doing to our environment, right? To reduce the strain on the power grids, right? Enhance comfort and performance, increase access for others. So the less you use, then there's more for your neighbor to use, or there's more to go around, right? And then of course with compliance with global standards and regulation, right? Okay, so what are the tools transforming energy consumption or energy efficiency? If you recall, when I was talking about the value chain, I talked about smart tools. Sensors and remote sensors, are major tools that we use right now. So if, for example, you know how to code in any form of hardware, say maybe like Python or C or things like that, it's a very interesting resource right now, because everything needs to be tracked, right? The data that we collect from every value chain is actually very important. You know what happened? So some of the grid systems that I manage personally, such as the one in my house or in my office, and some clients, the ones we've deployed for some clients, in the past, I've been managing the dispatch through a remote software. And that software got updated 2 months ago. It got updated with AI features. And what I've then done is, instead of handling those things manually, I've then handed it over to AI to manage it all by itself. And guess what? While managing it myself, I was able to save maybe about 55% on the energy bills. With AI managing, the lowest it's gotten day on day is 75%. So just to get you thinking, and what does this infrastructure entail? Number one, the sensors on the inverters, the sensors on the meters is being sent to the back end, right? And with that true information, we're able to get billing data, we're able to get consumption data, we're able to get the resource data, so it knows how much power is available from the PV. It has weather data, and with all of this data, it's able to configure the inverter at different times of the day, and then to the end that it saves about 75% on the electricity bills, right? So again, and we have a mobile app that it provides all that information on, right? So that's just one example, you get, of how technology is being used. And it starts from developing hardware, most times sensors, to be able to collect data, you get, and then with that data we then go into machine learning on how to manage and use that data, make sense of the data, create different dashboards, and again, this comes, with, data science is such an important aspect, right? Data analytics, another aspect, and then, machine learning, another aspect that you can think about, as career paths that would be extremely useful, in the energy and the future of energy of tomorrow. Another part, of course, like I said, is effective and efficient hardware, and that's where the electrical engineers come in, the computer scientists, the computer engineers, power systems engineers, are coming to make, even mechanical engineer. In fact, every form of engineering right now, comes together and are thinking about how to use less energy to provide more value, right? And you can even see this with electric cars, EVs at the moment, right? When that is essentially chemical engineers coming with batteries, mechanical engineers coming with gears and switch and things like that, and electrical engineers coming together as well to provide a mobility a device that would reduce fossil fuel dependence, and of course reduce. So I have a friend who just bought a Tesla in the US, and again he's saying nearly $400 in savings weekly or bi-weekly. I forget I think bi-weekly, saving about $400, right? And even his electricity bills has also been because what he now has to do is to then charge using solar sources. So his electricity bills is not even impacted. And in fact, he can use the batteries in the car to also power his house. So you can see how a lot of these things are coming together to play a huge part, right? So again, efficient hardware, appliances, motors, lightnings, and things like that, come together to help provide energy efficiency. And these are the technologies that are being currently deployed, across either in decentralized scenarios or an centralized scenario as well, right? And again, just like I said earlier on, in my house, for example, at this time of the day, even though the grid is available, I'm not taking anything from the grid, right? I'm being powered currently by solar, right? And then I have a battery backup as well. At night, it takes part of my okay, or when there is a power failure or maybe it rains, then I'm dependent on my battery, and then I'm dependent on the solar to charge the battery, and then I take very little when all fails, right? Is when I then depend on the grid, right? And that's one way to also, and of course, the deploying of this infrastructure is also a career path that you can think about. And we have a lot of women in that career path right now, installing, solar panels on roof, deploying BSS battery systems and inverters, even, for customers, either residential, commercial, and even in the industrial usage, right? And in many cases, you would see things like 65 to 70%, savings on your energy bill, are just relying on renewable sources, right? Smart metering, such an important part. In my profile, you would see that for the Nigerian military, we've saved them and still counting, over 75 billion naira in the last 2 years. And what we've just done is, deployed smart metering, collected data, and with that data, figure out where the wastages are and just go cut down on those wastages, right? So we have data scientists look at those data and advise the engineers on how to, improve, those losses and those wastages. In some cases, we have what we call the tanker losses, right? And the engineers come together to either fix the substations or substation equipment, and then provide, better intelligence and better power. Could you please mute? Happiness, could you please mute your mic? Thank you. Happiness, could you please mute your mic? Or could admin, is anyone, could the admin mute, please? Can someone please help with this, please? Okay, thank you. So in summary, some of the things that I said earlier on about the career pathways for you, energy auditors and consulting. I mean, that's a very exciting space at the moment, right? Data analytics and IoT engineers for smart grid systems. Another thing that I have not talked about is policy shapers, advocates, and green entrepreneurs. And we have a lot of people in this space, so you don't have to be an engineer, you don't have to be a coder. Do you get it? I've got friends who are lawyers. I've got friends who, studied, policy planning and things like that. And why is this very important? You get some of these things we need to, for lack of a better word, codify or make them policies or laws, right? So that we can stimulate growth in those areas. So for example, right, if you don't make a policy, that there would be, say, for example, and this is something you can go and research, what is called the carbon credits, right? There isn't any policy around carbon credit. There is no incentive for people like Shell, Mobil, and all of these big oil companies across the world to invest in renewable and stop, or divest from their oil dominated assets and things like that, right? So you'd see that policy actually plays a huge part, in the work that we do. People who also invest their time in advocacy, it's also very important, right? They bring awareness to you and I, to everybody across Africa, across the world, telling about the problem, identifying the problem, for you engineers or whoever who wants to solve those problems, and it's very important, getting the government thinking in the directions that they need to think about, right? And, that ties into what the green entrepreneurs would then go and solve eventually. And just like I shared earlier on renewable systems, designers and developers. So some would design the systems, some will go on to implement and deploy those systems, right? And then people would also invest, in developing different softwares, energy softwares. Now we have things like what we call the building management system, which is essentially an infrastructure that manages the entire building. You're deploying smart devices across, the building, and then you have a brain that then manages it to say, what, this is the time I'm going to I'm going to activate the dishwasher around this time because maybe energy is cheapest at this time, or we're using solar at this time. So we're going to decide to do all the washing and ironing and, your dry cleaning about this time. And then, or we would also, heat up the water around this time of the day when energy is cheapest, so that you have hot water to use maybe earlier in the day or in the evening when energy is more expensive or the demand of energy spikes, right? So you have different systems, that is being deployed, and different software that is being deployed across the different value chain. Right. And of course, this equipment and appliances themselves are becoming more and more efficient. Like you take the light bulb, for example. The light bulb used to be very power hungry. If you wanted brighter, in fact, before, when we talk about incandescent bulbs, it used to be directly proportional. So the brighter the luminosity or the brightness of a light bulb was directly tied to the more power, that it would take. But right now, that's not the case. We have, low power or more energy bulbs. You have things like 5 watt bulbs that are even brighter than 60 watts incandescent bulbs. And a lot of research is going into that as well. Smaller LEDs, being created and being put together to provide brighter luminosity or greater luminosity that would then provide, would use less power. Same thing is happening with our air conditioning system. Most of the big players such as Panasonic, Brom, LG, and Co are now promising things like 70% efficiency on their cooling devices and so on and so forth, right? So these are the career pathways. And what's the vision for the future? The continent is powered by clean and efficient energy. That is the goal, right? To use to tilt towards more renewable sources, and more efficient sources, which again could mean hybridization of those sources, where we don't actually, because I'm one of the people who think that we're never going to be able to phase out completely in a short period of time fossil fuel. But what we need to do is to increase the reliability of renewable sources, extend the intermittency, or solve the intermittency problems of the renewable sources. And what do I mean by that? So again, you only have sun, averagely across the world for between 8 to 10 hours, right? And then you have the darkness, and then the solar panels are no good. Even though a lot of people are then some people are doing a lot of research around making solar panels be effective at night, right? So we need to solve that problem, right? Because we know we need energy 24/7, right? And that's why solar, hydro, wind have to be hybridized, so that when you have downtime from the sun, right, or when the sun goes down, you have another source that can kick in to meet that gap and even meet your needs as well, and to dispatch all of those things very, very smartly. Another thing is then we're building smart homes, smart industries, smart cities. And this is another opportunity for architects, for engineers, right? Infrastructure engineers and things like that, to build smart things, and it's not just smart in the sense that you're building, you're adding maybe chips or sensors, even the way we build, for example. So for example, a lot of architects are speaking about how to position your home in such a way that it maximizes sunlight and also maximizes ventilation, so that you need very little cooling in that space to be able to achieve, versus, building in such a way where the spaces are naturally hot and you need more air conditioning or more powerful air conditioning to cool those spaces, or you need to put more light bulbs to light up your homes. So this also falls within what we call smart homes and smart building, smart industries, and smart cities, right? And of course, driving youth innovation and entrepreneurship. So in conclusion, learning, you have to keep learning, right? I'm happy that you're in a mentorship program such as this. Please take as much courses as you can, hand-on projects and things like that. I commit to taking at least 3 courses every year, right? And sometimes some of those courses are a year long, right? Just to get better, to understand more, to learn what other people are doing in different spaces, and to be able to, understand more the problem, and then look at what the solutions and how other people are thinking about the solutions to such problems, right? And of course, apply efficiency in our day-to-day lives, right? And collaborate with others across different sectors, and of course, be bold. Africa's energy's future is in your hands. I'd like to close by just playing a very short video, and I hope it plays out. Please tell me if you can see and hear the video.
Energy saving begins with us.
Thank you. I'll take questions now. Can anyone hear me?
Hello. I don't know if it's just me. I could not see or hear the video.
I'm sorry. So I'll make the slide available so you can watch it. I don't know, maybe it's something I'm doing wrong on Zoom. I don't know. Well, this is a short video just to surmise how, everybody has to take responsibility with energy efficiency and managing energy across the value chain. Any questions?
I do have one question. Can I go ahead?
Yeah, sure, please.
Okay, so thank you very much for sharing. It was a very inspiring presentation. So I heard you mention mostly on people in doing machine learning and engineering. So for me, I am part of the data analytics and storytelling team. And I would just like to know what opportunities are available for data analysts in the energy sector. Maybe I missed it because my network was breaking here and there.
Yeah, so like I said, the current energy space in Africa is undergoing what we call an overhaul and deployment of smart systems, so smart meters, sensors. And what we're trying to do essentially is we're trying to collect a lot of data, right? And with that data, of course, you know that data tells a story, right? And what do we want to use that data for? We want to use it for diagnostics, number one. So from an engineering standpoint, you want to know where your losses are and where you're not being efficient, right? Another part is for transparency and accounting. So we want to be able to track the money and follow the money. We want to know where we're losing money, do you understand, and where we're making money and where we should be focusing all our energy. So we want to be able to make business decisions with this data. Also for transparency. So the end user wants to understand that, look, I'm not being cheated out in any way, right? So all of this comes together, right? And all the data that you collect, you can, reuse all of this data or combine them in different ways to determine how, energy efficient you are being, how technologically efficient you're being in terms of power generation or power distribution or power transmission, right? And using the data that you collect to do your work properly. I'll take the transmission company, for example. The transmission company, they do a lot of work in balancing, a generation, balancing distribution and balancing demand. And they do that manually. So they've got like, a control room where, they're looking at all of those things. And that's why I told the story of, how I then use AI to do that automatically. And he did that at least 25% better than I did it, right? Do you get? And essentially just collected a lot more data, processing it and, using it over a long period of time and able to make a better decision than I, for a specific time of the day, right? Make it more simple. So for example, it's collected enough data to know that around 10 o'clock, this is the behavior, when it comes to generation, this is the behavior when it comes to demand, and this is the behavior when it comes to the infrastructure. Do you get? And then looked at it and looked at where the holes are and say, okay, is generation being efficient? Are we generating too much at this point? Because if you're generating too much, then you're more likely to be burning fuel or losing a lot of energy, right? So it will then optimize and ramp down generation to be able to meet the current demand. Do you get? And that little thing that I've just said could save you hundreds of millions of dollars per day, per time, stacks up over a period of year and stuff. And if you then go into how these projects are being funded, for example, you'd see the huge value that brings. So for example, the funding of this infrastructure usually goes into millions and billions of US dollars, for example. And most times it's been financed by big banks, FDIs, and things like that. And you'd have on your spreadsheet how you plan to pay back all of those things. So you understand that if you can design, using data to make us more efficient and save us money or make us more money, then you would understand that you can then pay off your investors even in a shorter period of time, and you can get to your ROIs, really, really quickly. So you can see the value of what data would bring, and data storytelling and things like that would bring. Essentially, even bringing it more back home, one of the ways that we used to save the Nigerian government and most of our clients a lot of money is through this data as well, right? So I take one of my clients, for example, IHS Towers. They build towers for telecommunication, and those towers have to be up 24/7, right? So when there is no grid supply, they're running on diesel, right? And we've built a dashboard for them just to show them that when they're not being powered by electricity and they're running on diesel, this is how much they're spending. And then we've shown them that data, and then it's now occurred to IHS that it makes sense to actually deploy a lot of money, not in procuring more diesel generators, and to spend that money now in providing better energy access or grid access for their towers, because the numbers just jump out. Levelized cost of energy for their towers on an average is about 65 naira per kilowatt hour, whereas if they're generating on diesel, it goes up to about 800 naira per kilowatt hour. As you can see, so why am I buying more generator if I can actually sit down with the distribution company and invest in the infrastructure to provide me better energy? I will get to my ROIs faster, right? I would run more efficiently, and there was just more money for the company to spend and to do whatever it is, either for expansion or to pay staff or whatever it is, or even CSR. I hope that answers your question, Angela.
Yes, it does. Thank you very much.
You're welcome.
And one more thing.
Okay.
I heard you mention hybrid energy. So I would assume that would come with big data. So, like, are there any challenges that would be faced when implementing hybrid energy with regards to data?
So again, maybe not in the rest of the world, but again, in Africa, we have that problem, right? So for example, when I'm designing a hybrid system, I need data when it comes to, number one, the climate data or the atmospheric data, or so I want to know, what in the past 5 years, what has been the sun hours, right? What is the sun intensity, right? What we call the methodological data, right? Now you find out that in Africa, for example, we don't have the most reliable or the most accurate data, right? And most times we have to, so maybe, for example, if you are lucky to have an airport close to your project site, then your data reliability becomes better because they have sensors at the airport tracking all of these things, right? And you might be able to get, a better data. Oftentimes, what is even recommended in very remote areas is we then take a logger and go and deploy it to the site, maybe for a 6-month period or a 3-month period, depending on how urgent or how much time we have in the project development phase. Well, you then put a logger to then collect that data for you, whereas that's not a problem in New York or anywhere else in the world, especially in Europe. Most of the softwares, that we use in designing this hybrid systems, you're able to just, with a click of a button, download, for Boston or for Lithuania or some parts of Europe very quickly with a touch of a button. But you would struggle to do that to find, in very remote parts in Africa. Right. So that's where data comes in and where problems with hybridization comes in. Because if I, for example, cannot estimate correctly how much sun I will be getting over the life cycle of my project, right? If I've made an assumption that I would get more sun, it would affect the way I would size the other systems, right? If I assume, maybe, for example, I assumed, oh, I'm going to get maybe 16 hours of electricity, of sunlight, right? Or sun power, right? I would, because again, that's probably going to be like my cheapest source. I would then downsize the battery packs that I would need, In this case, I'm trying to hybridize solar and battery, right? And if I wrongly assume that I'll get 12 hours of solar, you'll notice that my battery bank will be smaller, right? And then of course, when it gets into implementation, then my end users will then start to complain to say, you know what, I promised them 24/7 electricity and I'm not able to deliver that. And that's because of the assumptions that I've made, right? But then if I'm able to accurately determine that I'm only getting to get 8 hours of sunlight, and this is the amount or the quantum of sunlight that I'll get within that 8 hours, then I can correctly size my battery packs, right? And even my solar panels to be able to harvest, and then to meet the end users needs. You understand what I mean, right? So that's where data comes in, and and that's how we affect hybrid systems, right? So the better data that you have, especially when you need to design the projects, the better, right? So for example, we take even hydro, for example. If I can estimate correctly the flow rate of water, right? Then my project is doomed on day one. I hope that answers your question, Angela.
Yes, thank you very much.
Yeah. Any more questions?
Yes, good morning, sir. Please, can you hear me?
Yes, I can hear you, Precious. Please go on.
Right. So my question is, you talked about electricity and subsidy and everything, and then understanding how good and how beautiful and how useful using solar for electricity is and all of that. I feel like solar is quite expensive. It is very, 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 like if you want something reasonable, you have to spend like a huge amount of money. So if the government understands that it's good that we have solar and people understand that it's good that we have solar, is anything being done to maybe subsidize solar or to make it cheaper so that people can afford it?
Excellent question. Now, one of the ways in Europe and in the Americas at this moment, there is a subsidy, right, on solar and solar equipment, right? Also in advanced grids, they even allow you to sell back your self-generation, to do what's called net metering. So for example, if you bought 10 naira from the grid, but with your solar, you're able to export 5 naira back into the grid, then your net bill will then be 5 naira, right? So in a lot of advanced economies, there's a lot of subsidy. Unfortunately, in Africa, the problem we have is that we're not manufacturing all of these things here. So a lot of these things are dollar tied. So when our currencies fail or do poorly against the US dollar, these things become more expensive, right? To a large extent, there has been some subsidies from the Nigerian government, for example, where importing these things, are import exempt. Do you get, like if you want to import batteries for solar or solar projects, they're exempted, from VAT and import duties, right? So some of these things have been applied. Unfortunately, there are a lot of economic factors that Africans and Nigerians are grappling with, that some of the subsidies don't then trickle down to you and I eventually. So I agree, yes, it is very expensive. But one of the things that has been propagated the most right now is financing of these projects, especially for residential and commercial users. Right. And there are a couple of banks that are thinking about how to finance this assets for their clients, where you pay next to nothing or pay a small down payment and then pay for this asset over a period of time. And the rationale is that the savings that you make, you can plug that savings back into paying, for this infrastructure. Right. So that's what is being done in Africa. And I'm sure that if you Google, you find that, people are offering, different, down payment options and paying over a period of time and things like that, But in a more advanced economy, this is well structured, where once you deploy renewable sources, your tariff will go down. You're allowed to do what is called net metering, and you're also able to get, some credits for deploying the systems. I hope I answered your question, Precious.
Yes, thank you.
You're welcome. Any more questions?
All right, I think there's a question in the chat box from Opayemi.
Okay, let me see. Yeah. Okay, so how is energy efficiency sustainable for those in the rural areas? Excellent question. I hope that's the first one. Okay, good. Okay, good. So, good question. Number one, you call I was talking about energy efficient devices, right? In most rural areas, the demand is also low. So, with solar panels, with solar heating devices and things like that, right? It would help, right? So, for example, in rural areas, they don't have the flat screen TV, computers, AC, and so on and so forth. So usually their demands are low, right? So with smaller systems, you're able to meet their demand. Also, I must add that one of the major ways for rural penetration for renewable devices is what we call productive use of energy. And what is productive use of energy? Productive use of energy is using energy to produce something that you can sell, right? A commodity of some sort, that you can sell. And why is that important? So you understand that if, for example, in my house, like I'm at home right now and I'm burning energy, right? It could be harder for me when I'm just, using energy for leisure. So, for example, I had no job to do, and all I do is just watch movies, turn on the AC, just, have a great time, right? Versus if I then was creating something with the energy that I'm using, something that I can sell, right? You'd notice that I would then be able to pay for that energy much more easier than when I'm just using it to do nothing, right? And one of the problems in Africa and in major parts of the rural is we use energy for leisure. We're not producing anything, and when we start to produce stuff with it, right, you then have a commercial business, and the cost of that energy is borne by whatever commodity that you sell. So, for example, if it's a huge rural farming community, right, that they would need energy for maybe storage or for one farming activity or the other, you find out that in such communities they are likely to be able to afford the cost of energy. Oftentimes, even if they are not able to afford, because there are two costs. There's the capital cost, which capital expenditure cost, for short, we say CapEx, and the operation costs, or operational expenditure, which we call OpEx, right? And what you find out with, especially with renewable renewable sources, is that they have high capital expenditure costs, high CapEx, but very low and sometimes next to nothing OpEx, right? Whereas with fossil fuel, you might have a slightly cheaper CapEx, but a very high and consistent OpEx, right? So to put things even more simpler, if you buy a diesel generator, for example, it'll be cheaper than buying a solar and battery, inverter, right? But your diesel costs every month or every day, you have to buy diesel. You have to every month or maybe every 100 hours, you have to service it. So you're buying more oil. An engineer comes in to do the maintenance of the filter, the generator, this and that, and then you get it running again. And then every time you're running on diesel, right? So you can see that there's a lot of associated costs to that. But then you have the solar inverter. Once you install it or you pay for it, then that's all. It keeps running. And if you buy a good system, you would, for the next 10 to 15 years, you don't have to worry about it. You just maybe have to do some routine maintenance, which is cleaning the solar panels and cleaning the battery terminals and ensuring that the inverter is in a cool place and does not overheat. That's all the maintenance you have to do, right? So you can see both of them. Now, what's happening now is that communities or rural communities that have productive use cases, you find financiers coming to invest in those rural areas, knowing that whatever savings that they make, they're able to plug it back and then pay back the financiers, right? So that's how to make it feasible for and sustainable for rural communities, is to encourage them to have one form of productive use or the other, right? So for example, if they have export value for cashew or for rice or whatever it is, and then they need electricity, of course, for storage, and of course, for their residential purposes, right? You find out that, that's how to make things sustainable in rural areas. And of course, deploying, these devices that are very efficient, and finding a financier to cost all of these things is how to make it sustainable in rural areas. Again, you say, next question, I think it's another question. Green energy sources such as solar, windmill, hydro contribute to improving energy efficiency. How can these concepts relate or different in practice? I'm not sure I understand the question. I don't understand. Okay, could you please unmute, and maybe I'm not reading this correctly. Contribute in improving energy efficiency, or how can they? Okay, I think maybe I understand now. So like I said, because they're renewable sources, they're self-generating. As long as God does not turn off the sun is going to show up tomorrow, right? And it's free. Once you've bought the solar panel, you can generate energy. Unlike when you have to go and buy fuel or diesel, or you're buying from the grid, right? You'd notice that your bills would keep coming up, or you'd have to expend, a lot more if you're using a fossil fuel. You understand? So that's how it relates. You get? So with wind, for example, on a windy day, you're generating, right? On a sunny day, you're generating. Hydro, most times hydro is in large scale, right? And a lot of power developers love hydro because it's the cheapest resource. They're not buying gas from anybody. They're just damming an area, right? And controlling the flow of water from one reserve to another that, will then move the turbines for them. And, you'd see that they're able to maximize profits when they're using, hydro, right? And able to sell energy cheaper to their customers and consumers. I don't know if that's the question you're trying to ask, and if I answered correctly. Okay. If you can unmute, could you just maybe give me a thumbs up or something if you can hear me and if I've answered your question? Okay, no response. Any other questions?
Can you hear me?
Yes, I can hear you now.
Okay, yes, sir. The question has been answered. I just wanted to know how these three green energies are related, and how they are also different, and the difference between the three. So yes, you've answered the question, sir. Thank you.
Okay, thank you. Thank you. Okay, any other questions? Okay, if there's over to you, Anchor admin. Feels like I'm done here. Thank you so much for the privilege to share. You can get my contacts, or you can find me on LinkedIn or Twitter or X as it's called right now. And we can interact if you have any future questions or looking for opportunities in the sector. Please do not hesitate to reach out. My name again is Ayotomiwa Adekahunsi, and I'm sure you can find that, across, the social media space. On LinkedIn, just put that in. I'm sure you find. And on X as well, I maintain the same name across all the social media platforms. Thank you guys, and best of luck in your future endeavors, and best of luck with the rest of the program.
Thank you very much, sir. We appreciate you for sharing your insights with us. And we thank you very much for all that you've done. And I'm sure they'll request for your number, and then I hope I can share your contacts with them.
Yeah, absolutely. That's fine.
All right. Okay, so I think we've come to the end of today's mentorship session. Thank you, everyone who turned up. And I think we'll share the recording with those who couldn't make it today. Thank you very much, Mr. Ayotomiwa.
Thank you for having me. Thank you.
Yes, sir.
Bye.
All right. So good luck, guys. Bye.
Bye. Thank you.
Yeah.
Bye.
Thank you, Ma.
Thank you.